Hi, welcome to another 4AC learning video. This is a continuation video of lecture topic 4, where now we look at the power triangle. Now in the earlier videos, we look at power, we look at the real power, we look at the reactive power, and then we also look at the apparent power. Now in the complex form, we can express the various power in this way. The real power P is actually V times I, which is the apparent power, cosine of the phase relation or phase difference between the voltage, incoming voltage supply, and the current coming through the circuit. And the reactive power Q is similarly related to the apparent power S and the sine of the phase angle, the difference in the angle. So in other words, if we were to express the various power in the complex form of the vector domain, we can write it as S with the little tilde on top is actually the real power P plus J, the reactive power S, Q in this case. Alright, again, if you were to recognize this format is the phasor diagram or rectangular form of the phasor version, and we can write it similarly into the polar version as S, which is the magnitude of V times I, angle, which is given by the angle difference between the voltage and the current. Similarly, we can write in this form where S bracket cosine theta plus J sine theta. They are all related. So we can then use this to draw the what we call the power triangle. So what is the power triangle? You can look at this in the form P is in this way, which is in line with the current or in the same direction as current. Q is difference of 90 degrees, and the apparent power is formed by the hypotenuse of this right angle triangle. So we can write in this form J and P. At the same time, we can also present in this form. Okay? So both represents a what we call is a power triangle, and it's going to be useful when we analyze how to improve a power factor and so on. So in the complex version, we can say complex power is actually the phasor S apparent power is the phasor of the voltage incoming supply, phasor of the current with a conjugate. Right? I with the asterisk is the conjugate of the current I. So what does that mean? Notice if I is 3 plus J4, right, then the conjugate of I is just 3 minus J4. Notice the difference, right? And we have a negative sign as well. So that's how we use it for calculation. Alright, at this juncture we have an example 4.2. So I will urge you to watch the video which will be created specially for example 4.2. So that's all for this particular video about power triangle.